Okay, so I gone over the Wolf project here and see that we have a fundamental problem that is not going to allow us to use a layered blend per bone to correct for facial animation based on this desired output of want to use the neck, but not affect the left and right clavicle. And it's simply impossible to do as additive or as a layer animation due to that relative connection based on the hierarchy linking of the left and right clavicle being linked to the neck joint. It's it's simply hardwired that if we say, for example, we select our neck joint here and we rotate the neck joint, you can see that our layering here, as far as the hierarchy goes, also affects the forward leg joints. And as an additional example of comparison of being able to rotate the head joint, which then doesn't affect the leg joints as part of that connection. The only way to solve this problem is to export the asset out to application of choice and relink the left and right clavicle to the spine 2 joint, which would be the correct way of creating that connection, even in a biped character. That's the way the layering of a hierarchical type of construction is normally done as best practice, even as far as biped character goes. You would not connect your left and right shoulder joints to your neck joint, as it simply would not allow for proper migration using the neck joint of a layer down that pathway, as the migration pathway will always be forward from the joint that the animations would be applied to. It's simply hardwired. It's something that you simply can't work around with any kind of accuracy as part of the Atom blueprint here as to how this is set up using a montage in this case, and then using the branch filtering that is available as part of the layered blend per bone. Now, this is a requirement because the normal connection is by isolating the various different parts of the character based on the migration pathway of that parent-child connection. So animation can be applied to, say, just the legs for the locomotion state, and the arms, which would be part of the torso, versus the head, which would also include the neck joint. So these are separate, isolated. Would normally have to be separated and isolated from one part of the bone construction to the other to allow for proper animation of the character and apply various different types of layers to sort of compound or basically like how compound interest works of being able to use the minimum amount of animations for the maximum number of different types of poses that you want to apply to it. So in this case, we would have to, if we wanted, say, for example, the character to bite left or right while running, we would have to have those poses available too, as well as being absolute, as to while running, the character would bite left or right. And the same thing for walking, and the same thing for whatever other extended types of animations that are applied to different types of poses. If our wolf here is crouching and being able to apply biting, and the only time that the animation would be applied as far as being correct would be in an idle state. And we can kind of demonstrate that as to kind of forcing our final animation pose, so we can see it in the viewer here without actually having to play it. So if we hit play, we can then test and see how our character is running. But we want to just basically use our viewport here within our anim graph to kind of see how things are progressing without having to hit play every time we make a change or recompile. So I'm going to go ahead and change the animation output pose to being absolute, as opposed to being, what the heck is that? Sorry about that. Without having to play each and every time we make a change and recompile. So let's start by just changing our full body output here, cache, to the walking state. And you can see over here we have our wolf is actually walking. Now, what's being used here too as well is this is correct as far as connection goes, but the actual montage to trigger this state is not as a layered blend per bone. It's not actually wired in, so there's no button that we can currently push. If we look at the event graph, the montage take is not actually set up in the event graph, and where it's usually would be to be able to activate it through the slot. So we'll need to disconnect that, and we'll add this as absolute animation to our per bone layering. So if we break this link here and we want to play the attack, see how that's going to be affected. So we can see the action in the viewport here. If we hit compile, nothing's changed until we add this as an absolute layering within our branch filter. So we'll add a filter and we'll change this to root. Now when we compile, our biting animation sequence will be playing. So this also involves the front legs and what have you. Now a bit of an explanation here of the difference between or additive and absolute is additive is a secondary action to a primary motion state. So let's say, for example, we also have an aim offset that is included into our migration pathway here. If the player is aiming up, for example, we can add an aim offset so the player can add an aim up, down, left, right, pitch, yaw, etc., etc. Then, let's say, for example, the player is aiming upwards, then fires. Then the additive state would be the as part of the aim offset would be the action of the player firing on the weapon, which is then additive by the aim offset. So not generally used as part of the layered per bone, which in a lot of cases we want as an absolute value, but simply applying the state change to a particular bone. So in this case, our desired output would be the neck. So since we have the attack being applied as an absolute to the full body, based on the migration pathway of the animation moving forward from the root bone, and anything connected to that pathway as a parent-child, then we'll receive the animation data. So in this case, based on the description, we say, okay, we want to apply the animation to the neck, and we hit the compile button. We get these really weird animation being applied to the legs, simply because the animation is moving forward from the neck forward. And as I pointed out in our graph here, that would include the left and right clavicle, which then would have to be connected to spine 2 to exclude it as part of the pathway as far as the layered per bone animation goes. Now there is a way to kind of force it to exclude it from this pathway, but unfortunately we've got a kind of a problem here where the orientation of the legs is driven by the position and orientation of the neck joint. Another example of this is, say for example, if we have facial clusters set up for lip sync animation, and we decide, okay, we're going to link all our joints to the neck joint. Since the two are not directly related to one another and has a relationship, as we have with the head joint and the jaw being connected to the head, and the left and right ear joints and cheek joints and the eye joints all being connected to the head joint. If they're connected to the neck, then their orientation would be offset based on the orientation of the neck and not the head. So if we move the head left and right, then our joints will no longer line up, and then I would expect all sorts of weird deformations taking place. So this could be the problem that you see sometimes where the face joints just simply don't line up properly, as they're just simply not linked to the appropriate joint locations. So as I mentioned, the only way to correct this would then is to output to a different program or send the creator of this setup here a message saying that this stuff needs to be fixed. as they're not actually correctly done as far as parent-child goes, as to the need and desire to create separate sections of our character here that can be independently animated from one another. It'd be kind of like if we took our head joint and connected to our pelvis joint. If we reorientated the pelvis joint, of course, that would cause the head joint to move and be offset from and isolated from its segregation as being a component of the head joint. Simply cannot animate around it. Now, we do have options, though, based on really on the extent or the amount of limitations that we really just need this particular character to behave. Now, since I've gone ahead and actually directly applied this, we can do a quick fix here by adding the target joint higher up in the hierarchy. So we can apply the target to the head, for example, and now our character here is walking and snapping and growling, and the head is moving around and the ears are moving backwards. So it's a predictable and a much more ideal output as far as that need to have the character be able to have locomotion applied to it. But once again, we're kind of jumping over the fence, so to speak. But it should then be able to apply our locomotion to our full body output. And now if we hit the play button, you can see we got our layer working, and our character is running around, and you can see it snapping and whatever. Now, taking us forward, as I mentioned, this is a rather simplistic type of character here. So if we go to bones and we go showing the hierarchy. Now, if we're dealing with a much more complex character, say a biped character that's set up for lip sync animation, we can then even take things a little bit more further as far as isolation, various different elements, and applying the animation directly to the desired target joint. Based on the idea of, okay, we don't necessarily want the head to move around, we just want the jaw to open and close. So we can then just check our animation hierarchy linking, and we go, okay, well, we have a candidate here. I call the jaw. So if we change this to jaw, and now we compile. Now so now we can see that our animation is being fully applied within the full body pose. But then only the joint for the jaw is affected as far as opening and closing. Could be a talking wolf if you wish. Let's disconnect this and hit compile. And you can see that to get our base pose, as we have 0 data being fed into our full body cache, which gives us our base pose, and you can just see that the jaw joint is definitely is the only element within our hierarchy that's actually being animated. So if we apply a locomotion state here, and then now it's walking. If we had, if we want, we can add our full animation take to our attack bite to that joint. I think there's another one in here we can add. We have forward walk, forward run. Okay, we'll add forward run just to see that we can create these as absolute output poses. So we can kind of extrapolate this as proof of concept that we can have a biped character walking around and talking at the same time and doing all these different actions based on the layering that we're going to apply. So the player can be walking, swinging a sword around while talking, while blinking, and etc., based on how we apply that as a layer. Okay, so let's put this back to our walk forward just to kind of take this a little bit step forward. And if we can see that we have the jaw opening and closing, what we can do now But as we noticed that hopefully in our full body playing action here, that the ears are also involved. We can actually add those as a branch if we wish by adding a couple of branches. So we have our first branch goes to the animation is being channeled down forward from the jaw forward, but we want to also include the ears. So if we look at the ears here, we have left ear and right ear. We can force our animation to branch to the ears, so we can add that. There's our left ear, and there's our right ear. And if we compile, now our character is walking, and the ears and our animation data is opening the mouth, and the animation data that's been applied to this layer is also operated in the ears, but is not affecting the eyes or the cheekbones that that make up our facial clusters. Now this could apply to other things, like for example how I like to set up my character for animation for lip sync using clusters is I'll include the joints that make up just the mouth joints. So I'll have whatever's applied to the lower jaw and the upper jaw, and that would then isolate to the various different joints for the lips and what have you. So the mouth is the only thing that gets animated is the mouth joints. This allows you to apply procedural type of animations to, say for example, the eyes or even facial joints that you can use to create facial expressions for the eyebrows and etc. separate from the necessary joints that are required for the dialogue. So you can have these various different tracks where you can kind of start compounding the amount of animations that you have access to without actually having to animate it. So as I mentioned, for example, eye blinking can be procedural based on a formula of the natural tendency of the eyes to blink, or any type of joints that need to be a companion of. In this case, for example, we've kind of demonstrated the ears moving within the same branch state as the mouth, as that would be the expected type of animation data that should be applied for those types of actions. Okay, so that kind of explained. Let's kind of clear this out and kind of demonstrate the isolation type of idea, except to also illustrate the problem that we have here in the grander scheme of the problem that we have as far as applying the animation to the neck. So we'll trash everything. We'll just add our neck joint back in. Now if we compile, we get this funky action happening with the legs again. Now we can correct this by creating a new blend pose to kind of bypass it. So we have this action of our neck and the animation moving forward from the neck, but we want to reapply back to our animation to which would normally be the legs, and it's isolated in this or to exclude the joint. Now we can do this, for example, if we want say the neck joint to have a different set of animation from the actual head as to orientation. A good example of this is we can have the head actually looking left and right through a separate layer, say from the actual head itself with the facial clusters that are attached to it. So this is where, once again, we're talking about additive type of animation where the wolf could look left and right, but at the same time you can put in a layer as an additive where if it looks left it can bite, if it looks right it can bite, without having to add unique types of animations for that particular need. So you would have look left, look right, bite, and then bite. And then when we add that as an additive, you could have left, bite, right, bite. So you can see how it compounds. We have one additive animation of the bite versus two animation of the character moving left and right, instead of having four, and etc., etc. Now, as the more you add, it becomes more and more obvious of how these types of animations start to compound like compounding interest, so to speak. So unfortunately, the way this hierarchy is connected, though, the legs as being arms would have to be what would be called absolute animation, because we wouldn't necessarily need for those primary joints to be as an additive in most cases. So I hope it's not too confusing, and hopefully that by demonstrating here it becomes a little bit more clear. So we have our neck joint that is driving this, and we have and normally we would say, okay, well, let's exclude the animation as being applied to a given joint. So normally we would say, okay, this would be the neck, and then we would put an exclusion in as far as excluding the neck, but still driving the head, for example. So we would add a pin, and we would want our base pose to be, in this case, be the data coming from the base pose. If, say, for example, we wanted to exclude a joint, that data, but we want the data has to come from somewhere. It has to come from either an animation take or from the full body pose to actually exclude that type of information. So we would have our base pose, and then in our base pose that would add a layer setup, and then in our layer setup we would have to add, in this case for the example, we would have to add 2 branched filters. So pay attention to what we've got going on here as far as how things are being animated. So we'd select our left clavicle, which would be our left shoulder joint in a biped character. We would copy the selected bone name, and then in our layer for bone, we then add that in as a left clavicle, and then in our number 1 layer here, we would add a right clavicle. So if we go compile now, okay, that's not really acting the way I would expect it to. Let's see if we actually take our wolf attack here and we plug that in. Let's see what we got. Oh, no, we need our walking pose. Where's our walk forward? Oh, okay, there's our walk forward. We need a copy of that. And we take that down there. Let's see. Is that correct? It's really hard to see. Yeah, it's actually walking. It would be normal walking versus the playing animation of the attack bite. So there's our other attack bite. So let's see if we can see the difference here. Hit the compile button. Okay, see how the animation that's being applied is actually part of the wolf attack, which is the same thing as what's being applied here. So if we say we want the full body to override it, we can add that, and we hit the compile button. Yeah, okay, so it's there's our walking animation. But you can see the problem is the neck is reorientating the legs, so it's always going to be a problem. You cannot, you could probably do it, but you would have to have, once again, you would be back to the problem of having to create an animation take to account for each and every absolute animation take being applied as the final pose. So I hope it's rather clear. It's on, as I like to say, it's on the other side of the fence. So you're going to have it, and the only way to correct that would be to relink the spine too, so it becomes, so that its parent-child connection becomes part of the torso and not part of the head. So I hope that's kind of clear. Okay, is there anything I want to go over on this? No, I think we've probably more or less covered some of the basics. I am planning on doing a little bit more, like this is an impromptu type of overview of what the problem is, but basically we have a kind of a foobar kind of setup here where the only real solution to our problem here is to more or less apply our animation to the head joint for that all-around biting action that the original post has kind of outlined as to the desired result. Okay. Sorry for mumbling on a bit. A little bit tired doing this first thing in the morning to get it done and over with before the work day begins. Okay. Enough of that. Bye, guys.